Hello students. In the previous video we had discussed continuity of functions. Today we are going to discuss differentiability of functions. Also we had discussed limits and derivative. The concept was already introduced in class 11 and you can refer the math practice video of limits and derivative class 11. Today we are going to study differentiability of functions. This is a one short video, so watch it till the end to get the gist of the chapter. We once again define derivative. Suppose f is a real valued function and a is a point in its domain. The derivative of f at a is defined by limit h tends to 0 f of a plus h minus f of a upon h. Derivative of fx, you know, it is denoted by f dash of x, and at the point a it is said f dash of a. An example is given. Suppose you need to find the derivative of the function fx is equal to 3x at the point x equal to 2. Then f dash of 2 by the concept of limit will be limit h tends to 0 f of 2 plus h minus f of 2 upon h. Putting the definition of limit, you get this limit to be 3. So f dash at 2 is 3. Now the notations for a derivative. Suppose you are having the function y is equal to fx. And when you are taking its derivative with respect to x, it is denoted by f dash of x or dy by dx or d of dx of fx or capital D of fx. So these are the notations for a derivative. Now suppose if you are taking the derivative of f at a particular point x equal to a, then you write it in the form given over here, d by d of fx at x equal to a. This is how it is denoted. Also note that the derivative of a constant function will always be 0. There is no change, so derivative of a constant function will be 0. We know that a function is differentiable if its derivative exists. A function f which is from u to r defined on an open set u subset of r is said to be differentiable at point a belongs to u if its derivative f dash of a is equal to limit h tends to 0 f of a plus h minus f of a upon h or limit x tends to a fx minus fa upon x minus a exist. Remember, both are equivalent. As your h tends to 0, x tends to a. As x tends to a, h tends to 0. Now if a function is differentiable, then it will imply that the function is also continuous at a. Also the function f is said to be differentiable on u if it is differentiable at every point of u. In this case, the derivative of f is thus a function from u into r. Now remember these statements. A differentiable function is always continuous, but a continuous function need not be always differentiable. We will see this later with an example. If a function is not differentiable, then obviously it will not be continuous. And if a function is not continuous, then also it will not be differentiable. So let us prove this result. If a function f is differentiable at a point c, then it is also continuous at that point. Thus, every differentiable function is continuous, but the converse is not true. We will show with the help of an example. First of all, suppose if f is differentiable at the point c, then by definition limit x tends to c fx minus fc upon x minus c is equal to f dash of c exists. For x not equal to c, we have fx minus fc is equal to, we can write fx minus fc as fx minus fc upon x minus c into x minus c. Take limit on both the sides. So limit x tends to c fx minus fc is equal to limit x tends to c fx minus fc upon x minus c into x minus c. Now the left hand side will become limit x tends to c fx minus limit x tends to c fc. And the right hand side, the first portion will be limit x tends to c fx minus fc upon x minus c. This is nothing but f dash of c into limit x tends to c x minus c. In that, when you put x as c, you will get 0. So right hand side is f dash of c into 0, which is 0. So ultimately what we have obtained is limit x tends to c fx is equal to limit x tends to c fc is constant. So it is fc only. So f is continuous at x equal to c. We have shown that limit x tends to c, fx is equal to f of c. So f is continuous at x equal to c. Hence every differentiable function is continuous at x equal to c. Conversely, if you remember in the previous video on continuity, we had seen that the function fx is equal to mod x is a continuous function. But when you try to find out the left hand limit of this function, you will be getting it as minus 1. Why? Because how will you define mod x? Mod x will have the value x if x is greater than 0, and mod x will have the value minus x if x is less than 0. So your left hand limit as x tends to 0 minus, that left hand limit will become minus 1, but the right hand limit will become 1. So f will not be differentiable at x equal to 0, since both the limits are not equal at the point x equal to 0. The limit does not exist, and f is not differentiable at x equal to 0. So we have shown that a continuous function might not be differentiable. Now some rules for derivatives we have already studied. Derivative of a constant is 0. C into fx, its derivative is c into f dash of x. Power rule, derivative of x raised to n is n into x raised to n minus 1. Means, for example, derivative of x square is 2x. Sum rule and difference rule, you know that. Product rule, derivative of fx into gx is fx into derivative of gx plus gx into derivative of fx. And the quotient rule, derivative of fx upon gx is gx into f dash of x minus fx into g dash of x upon gx whole square. Also, you have the derivatives of all the trigonometric functions. These need to be remembered. Some other rules. First of all, product rule is also called the Leibniz rule. So you know the sum, product and quotient rule. Now we also have the chain rule for derivatives. First part of the chain rule says that if you are having a function y is equal to f of g of x, like for example, if you want to find the derivative of sine of 5x, then the derivative will be equal to, first you have to take the derivative of the outside function into the derivative of the inside function. Means derivative of sine phi x. First sine, the derivative is cos, so it will be cos of 5x into derivative of 5x, which is 5. So this is how you use the chain rule. Another part is, suppose you are having a function y which is a function of t. So y is equal to f of t. You are also having x which is a function of t. Say x is equal to g of t. Now if you want to find the derivative of y with respect to x, means dy by dx, it is dy by dt into dt by dx, or you can write dy by dt upon dx by dt. Some points to note. If fx and gx are differentiable, then fx plus or minus gx and fx into gx will always be differentiable. If fx is differentiable and gx is not differentiable, then fx plus or minus gx will not be differentiable. Why? Because one of them is not differentiable, so fx plus or minus gx will not be differentiable. But fx into gx may turn out to be differentiable or not differentiable. If fx and gx are not differentiable, then fx plus or minus gx may be or may not be differentiable, because both of them are not differentiable. So if you take the sum or difference, after that the function might be differentiable or might not be differentiable. Similarly, if fx and gx are not differentiable, fx into gx may or may not be differentiable. When a relationship between x and y is expressed in a way that is easy to solve for y, then when we write y is equal to f of x, we say that y is given as an explicit function of x. Otherwise, if it is difficult to express in the above form, we say that y is an implicit function of x. Very simply, with the help of example, suppose I am having x minus y minus pi equal to 0. This can be expressed explicitly, means I can write y is equal to x minus pi. But suppose if I am having x plus sine xy minus y equal to 0, then it is difficult to write this in the form of y is equal to some function of x. Okay, so in this case you can say it is expressed implicitly. Derivatives of inverse trigonometric functions which are continuous functions can be found using the rules. We will see these rules and also using the chain rule for derivatives. Before going to other difficult examples regarding inverse trigonometric functions, let us first take simple examples. Suppose you need to differentiate the following functions with respect to x. Sine of x square plus 5. So derivative of sine of x square plus 5. First of all, sine, the derivative is cos. So cos of x square plus 5 into the derivative of the inner function. This is a chain rule. So derivative of x square plus 5 will be 2x. So the answer is 2x into cos of x square plus 5. Similarly, here also you are having, you will be using the chain rule. Sec of tan of root x. First of all, derivative of sec is sec x tan x. So it will be sec of tan of root x into tan of root x. Correct? See, remember here the angle, say sec theta. So theta, that angle is tan of root x itself. So derivative of sec theta is sec theta tan theta. So first sec into tan into derivative of the inner function which is tan of root x. So take care while simplification. So now what is the derivative of tan root x? Tan derivative is sec square. So it will be sec square root x into again derivative of root x. So what is derivative of root x? 1 upon 2 root x. Remember we are using 2 times the chain rule over here. So ultimately the derivative of the given function is sec of tan root x into tan of tan root x into sec square root x into 1 upon 2 root x. Now take this example. Prove that the function f given by fx is equal to mod of x minus 1 is not differentiable at x equal to 1. First of all, the definition of mod function, fx is equal to x if x greater than or equal to 0 is equal to minus x if x is less than 0. Again I am explaining this, like for example if you have mod 2 it is 2, but mod of minus 2 is minus 2 which is 2. So this is the definition of mod function. Now also we know the definition of a function, how to show that the how to find the left hand and right hand derivatives of a function. So first of all we find the left hand derivative of f at x equal to 1. So by definition that will be limit h tends to 0 minus, right, from the left hand side, f of 1 plus h minus f of 1 upon h. Okay, f of a plus h minus f of a upon h. This definition we are using. So now f of 1 plus h, according to the function given to us, it will be mod of 1 plus h minus 1, which is mod h. Now since h is tending to 0 from the left hand side, that means for example say h is a very small value which is say minus 0.001 or something like that. So if you see, the mod value for that will be equal to minus h. Correct? Why? Because h is tending to 0 from the left hand side. That means it is a negative value. Now when it is a negative value, by the definition of mod function, it takes minus h. Okay? So now left hand derivative will be limit h tends to 0 minus h minus f of 0 is 0. So 0 upon h, which is nothing but minus 1. Now the right hand derivative of f at 1, that will be limit h tends to 0 from the positive side. So that will be f of 1 plus h minus f of 1 upon h. In this case, f of 1 plus h will be mod of 1 plus h minus 1, which is again mod h, but over here as h tends to 0 plus means h will be a positive value. So mod h will be equal to h by definition of mod function. So f dash at 1 plus will be equal to 1. Now since both left hand and right hand derivatives are not equal, f is not differentiable at x equal to 1. Next example. Prove that the greatest integer function defined by fx is equal to box x, where x is between 0 and 3 is not differentiable at x equal to 1 and x equal to 2. First of all, let us check at x equal to 1. The function is defined? Yes, because f of 1 is 1. So function is defined at x equal to 1. Now remember, we have the two type of approaches to finding the derivative according to the definitions. So it says that f dash at a is limit h tends to 0 f of a plus h minus f of a upon h. Now see over here, h tends to 0 f of a plus h minus f of a upon h. So x is equal to 1 minus h. Why 1 minus h? Because it is tending to h. So x is equal to 1 minus h, where h is a very small quantity. So as x tends to 1, your h will obviously tend to 0. So you have to take over here x as 1 minus h. So as x tends to 1, your h will tend to 0. You want to express it in the form limit h tends to 0. So now using this definition of x, we find the left hand derivative, which is limit h tends to 0 from the left hand side. So limit h tends to 0 minus f of 1 plus h minus f of 1 upon h. What is the function fx? Fx is the greatest integer function. So it is limit h tends to 0 minus box of 1 plus h minus 1 upon h, which is limit h tends to 0 minus. Now over here, since your h is tending to 0 from the left side, so the value of h will be less than 0, correct? So 1 plus h, box value of 1 plus h, that will be equal to 0. So it will be 0 minus 1 upon h. Why? Because h is tending to 0 from the left side, means for example say h is minus 0.001, something like that. So it will be box of 1 minus 0.001, which is a quantity which is less than 1, correct? And how do you define the box function or the greatest integer function? It is the greatest integer which is less than or equal to the given number. So the number over here is less than 1. So the greatest integer which is less than that number is 0. So it is 0. So 0 minus 1 upon h. You know this is equal to infinity. Why? Because h tends to 0 minus 1 upon h will tend to minus 1 upon h or 1 upon h. It will be tending to infinity. Now right hand derivative. Limit h tends to 0 from the right hand side, f of 1 plus h minus f of 1 upon h. Now what will be the box value of 1 plus h in this case? Here h is tending to 0 from the right side, means suppose h is a very small value, say 0.001. So it is 1 plus 0.001. So the greatest integer less than or equal to that is 1. So the box value of 1 plus h in this case is 1. So our limit is limit h tends to 0 minus 1 upon h, which is 0. As both left hand and right hand derivatives are not equal, the function is not differentiable at x equal to 1. Similarly, check for x equal to 2. Fx is not differentiable at x equal to 2. Next example. Now we move to the derivatives of inverse trigonometric functions. Remember, you will need to memorize the derivatives of inverse trigonometric functions. Let us try to find or prove the derivative of sine inverse of x. On the similar basis, you can find the derivative of other inverse trigonometric function. So our example says you have to find the derivative of y equal to sine inverse of x. Now let us assume that sine of y is equal to x. Obviously y is equal to sine inverse of x. So sine of y is x. You differentiate both the side with respect to x. So derivative of sine is cos. So sine the y derivative is cos y into dy by dx. Remember, because again y is a function of x. So it will be cos y into dy by dx, which is equal to right hand side x. Derivative of x with respect to x is 1. Therefore, dy by dx is 1 upon cos y. Now already you know sine square plus cos square is 1. So cos square is 1 minus sine square, or cos y is root of 1 minus sine square, which is over here root of 1 minus x square. So now what we have is cos y is equal to root of 1 minus x square. So sine y, how did we get this? By putting sine y equal to x. Now put this value of cos y in the first equation. dy by dx is 1 upon cos y, but cos y is root of 1 minus x square. So our derivative dy by dx is 1 upon root of 1 minus x square. Correct? So now sin inverse x, the derivative is 1 upon root of 1 minus x square. Similarly, other derivatives are listed over here. You need to memorize all these derivatives: sin inverse, cos inverse, tan inverse, cot inverse, sec inverse and cosec inverse. Other important derivatives are the derivatives of exponential and logarithmic functions. The exponential function with a positive base b, which is greater than 1, gives the function y is equal to fx given by b raised to x. Correct? So over here b is a constant, b greater than 1, fx is b raised to x. Exponential function with the base 10 is generally called common exponential function, and suppose if it is with the base e, then it is called the natural exponential function. Y is equal to e raised to x. Also the log function is the inverse of the exponential function. Remember, log is the inverse of the exponential function. So how is it defined? It's defined as the exponent to which a base must be raised to produce a given number. So understand this log function. Say for x greater than 0, a greater than 0, a not equal to 1. If y is equal to log x with the base a, if and only if x is equal to a raised to y. So what is y? Y is the log. And what does log tell you? Log tells you to which power or exponent you need to raise your base. That means if x equal to a raised to y, y is that power. Y is equal to log of x with the base a. Remember this definition: y is equal to log x with the base a means x is equal to a raised to y. So what is our function? Our function is log x over here. If I write log x with the base a, it is called, the base is called a, and as I told you, the most common bases are 10 and e. Generally, if it is with the base 10, you write log, and if it is with the base e, you write ln. So now derivatives of fx is equal to e raised to x. Derivative of e raised to x is, remember, e raised to x. Derivative of log x is 1 upon x. Derivative of a raised to x means instead of e raised to x, that is a specific case. For any other exponential function, fx is equal to a raised to x, the derivative is a raised to x ln of a. Now you already know this, but these are some properties of log function which might be helpful in solving the examples. Like log of x into y is log x plus log y, and log of x upon y is log x minus log y. If I am having log of x raised to p, it is same as p into log x. Similarly, change of base rule says that suppose you are having log of x with the base a, you can change this to any other base, say b. How? Log x with the base a is log x with the base b upon log a with the base b. Also equality rule, if log x is equal to log y, then with the same base, then x is equal to y. So in the given examples, find dy by dx. First equation is xy plus y square is equal to 10x plus y. So now remember over here we will be applying the product rule because it is x into y. So what is the product rule? Derivative of u into v is u into derivative of v plus v into derivative of u. So x into derivative of y, which is dy by dx, plus y into derivative of x, which is 1. Derivative of x with respect to x is 1. Plus second term, y raised to n, derivative is n into y raised to n minus 1, means y square derivative is 2y into 2y dy by dx. This is equal to 10x derivative is x square x, and derivative of y is dy by dx. So dy by dx you take out common, you get on simplification dy by dx is equal to x square x minus y upon x plus 2y minus 1. Next equation You have to find derivative of cos inverse of 1 minus x square upon 1 plus x square. X is between 0 and 1. Now see, for these type of examples, looking at the example, you need to decide what will you substitute for x. So here you will take x as tan of theta. What is the reason? Because you know 1 minus tan square upon 1 plus tan square, that is cos 2 theta. Correct? So over here this should be done looking at the example. So if cos inverse of 1 minus x square upon 1 plus x square, take x is equal to tan theta. So now it will be y is equal to cos inverse of 1 minus tan square upon 1 plus tan square, which is cos 2 theta. And cos inverse of cos is the value of the angle. So cos inverse of cos of 2 theta is 2 theta. Hence y is equal to 2 theta, or y is equal to 2 into tan inverse of x, because our theta will be tan inverse of x. Therefore dy by dx is 2 constant. What is the derivative of tan inverse? Inverse trigonometric function, 1 upon 1 plus x square. So dy by dx is 2 upon 1 plus x square. Second one, y is equal to log of cos of e raised to x. Okay. So here we will again need to apply the chain rule. Dy by dx is equal to, first of all, log of any value is 1 upon that value. Log x derivative is 1 upon x. So log of cos e raised to x is derivative is 1 upon cos e raised to x into derivative of cos e raised to x. Again derivative of cos is minus sign. So minus sign e raised to x into again derivative of e raised to x, which is e raised to x. You are applying the chain rule 2 times over here. So ultimately the derivative is minus sin e raised to x upon cos e raised to x into e raised to x. Or you can also write as minus e raised to x into tan of e raised to x. Differentiate the function with respect to x. Y is equal to cos x upon log x. So first thing is we apply the quotient rule. U upon v derivative is v into derivative of u minus u into derivative of v upon v square. So over here the denominator will be log x whole square. Then it will be log x, numerator will be log x into derivative of cos, which is minus sine, minus cos x into derivative of log, which is 1 upon x. So dy by dx is minus of x sine log x plus cos x upon x log x whole square. Find dy by dx for x raised to y plus y raised to x equal to 1. This equation is given. Remember, we are discussing all different types of equations. Now over here you are having two functions, and you know that if you are having addition of two functions, the derivative will be also addition of both the derivatives. So to make it simpler, we take one by one. Let u equal to x raised to y and v equal to y raised to x. And it is given over here u plus v is 1. Now u plus v is 1 means derivative of u plus derivative of v is equal to derivative of 1, which is 0. So this is the first thing. So now first of all obtain derivative of u with respect to x. U is x raised to y. Now whenever you are having a function which is of this kind, means it is raised to some power exponent, then in that case it is very easy. If you are taking log on both the side, you have to take log on both the side and then differentiate. So now taking log on both the side and applying the simple rules for log, it is log u is equal to log of x raised to y, which is y into log x. Left hand side derivative of log is 1 upon. So derivative of log is 1 upon u into du by dx. Right hand side you apply the multiplication rule, y as it is into derivative of log x plus log x into derivative of y, which is dy by dx. So now what you do is 1 upon u du by dx plus y upon derivative of log x is 1 upon x. So y upon x plus log x into dy by dx. So second equation which we are getting is du by dx is u into, but what is u? U we have taken x raised to y. So du by dx is x raised to y into bracket y upon x plus log x into dy by dx. Let this be equation 2. Similarly, let v equal to y raised to x. Again take log on both sides. So log v is equal to x log y. Same procedure, differentiate both the sides. So we will be getting dv by dx. So dv by dx is equal to v. V means y raised to x into x upon y dy by dx plus log y. Now let this be equation 3. Now from all the three equations, what does the first equation say? First equation says that du by dx plus dv by dx was equal to 0. So just put the value for du by dx and dv by dx. Simplify means bring dy by dx on one side. So on simplification you get dy by dx as minus of y x raised to y minus 1 plus y raised to x into log y upon x raised to y log x plus x into y raised to x minus 1. This is simple simplification by bringing dy by dx on one side. So this is the derivative of the given function. Now for the next example, you are given that you have to find the derivative of x raised to sin x plus sin x raised to cos x. This is the function. So let y equal to x raised to sin x plus sin x raised to cos x. Again over here there are two functions, so let them be u and v so that it is easy for simplification. Let y equal to u plus v. So dy by dx is du by dx plus dv by dx. Let u be x raised to sin x. Now for x raised to sin x, again as I told you, something is there in the power, so you take log on both the sides. So log u will be sin x log x. Differentiate both the sides. Log u, derivative is 1 upon u into du by dx. Right hand side, use the multiplication rule for derivative. Sin x into derivative of log x plus log x into derivative of sin x. Derivative of log x is 1 upon x, derivative of sin x is cos x. Now du by dx take on one side, so du by dx is u into, but what is u? U we have taken as x raised to sin x. So du by dx is x raised to sin x into sin x by x plus log of cos x. Let this be equation 1. Similar pattern, find the derivative dv by dx. So v is equal to sin x raised to cos x. Again take log on both the side. Log v is equal to cos x into log of sin x. So now differentiate both the sides. 1 upon v dv by dx is equal to, again multiplication rule, cos x as it is into derivative of log of sin x plus log of sin x as it is into derivative of cos x. Now in between again you will have to apply the chain rule, because derivative of log of sin x is, first of all derivative of log is 1 upon. So derivative of log of sin x is 1 upon sin x into derivative of sin x, which is cos x. So what you get is cos square x, correct? So now ultimately dv by dx is v into, means sin x raised to cos x into cos square x upon sin x minus sin x into log of sin x. Let this be equation 2. Just put the value of dv by dx and du by dx, you will be getting dy by dx, because dy by dx is du by dx plus dv by dx. So the answer is given over here. Dy by dx is equal to x raised to sin x into sin x upon x plus log x cos x plus sin x raised to cos x into cot x cos x minus sin x into log of sin x. This is simple simplification. In the next example, you need to differentiate y is equal to x plus 1 upon x whole raised to x plus x raised to 1 plus 1 upon x. Correct? Again over here the same technique. You take the first function as u, second function as v. So y is equal to u plus v. So dy by dx is du by dx plus dv by dx. For u, again you take log on both the side because x is there in the power. So log u is equal to x into log of x plus 1 upon x. So now 1 upon u du by dx is equal to x into derivative of log is 1 upon that number. So x upon x plus 1 upon x into derivative of x plus 1 upon x. Chain rule you will need to use. Plus log of x plus 1 upon x into derivative of x, which is 1. In between, what is the derivative of x plus 1 upon x? Derivative of x is 1. 1 upon x means x raised to minus 1. So derivative is minus 1, x raised to minus 2. or minus 1 upon x square. On simplification, you get du by dx is x plus 1 upon x whole raised to x, means u, into x square minus 1 upon x square plus 1 plus log of x plus 1 upon x. Let this be equation 1. Similarly, we find the derivative of v is equal to x raised to 1 plus 1 upon x. Again, take log on both the sides. Remember, in this case, you have to take care by simplification. Okay, so just you have to use the chain rule, multiplication rule, but take care while doing the simplification. So similarly, we find dv by dx, which is x raised to 1 plus 1 upon x into x plus 1 upon x square minus log x upon x square. Put both the values, you will be getting dy by dx is du by dx plus dv by dx. Okay, so again, as I am telling you, you are applying the chain rule for the derivative of two functions. See students, we are doing different types of examples step by step. So next one, let y equal to root of x minus 1 x minus 2 upon x minus 3 x minus 4 x minus 5. So we can write the y as the whole bracket raised to half because root is there. Take log on both the sides. So log y is equal to half log of the whole bracket. Now we are having log of some fx upon gx type. So that is log fx minus log gx. And in the numerator you are having two functions which are multiplied. So you know when they are multiplied, the log is added, and when they are divided, the log is subtracted. So it will be simplified as log x minus 1 plus log x minus 2 minus the log of all the three, minus log x minus 3 minus log x minus 4 minus log x minus 5. Now take the derivative both the sides. So d by dx of log y, that is 1 upon y dy by dx. Right hand side half into first term log of x minus 1. So log of anything is 1 upon that thing. So 1 upon x minus 1 into the derivative of x minus 1. Derivative of x minus 1, x is 1 and 1 is 0. So derivative of x minus 1 is just 1. Second term 1 upon x minus 2 into derivative of x minus 2. But here also the derivative will be 1 minus 0, which is 1. So when you just multiply by 1, it is same thing, 1 upon x minus 2. Similarly other terms. So on simplifying, we will be getting, take y on the right hand side, dy by dx is equal to half y. What was y we have taken? The whole bracket square root of that. So it is half root of x minus 1 x minus 2 upon x minus 3 x minus 4 x minus 5 into 1 upon x minus 1 plus 1 upon x minus 2 minus 1 upon x minus 3 minus 1 upon x minus 4 minus 1 upon x minus 5. In the next example, you are having y equal to sine of tan inverse of e raised to minus x. So basically this is the implementation of the chain rule. So first of all, sine derivative is cos. Inside that you have tan inverse. Derivative of tan inverse is 1 upon 1 plus x square. Now what is your tan inverse of e raised to minus x? So 1 upon 1 plus e raised to minus x square into derivative of e raised to minus x. Derivative of e raised to anything is the same thing. So e raised to minus x derivative is e raised to minus x into derivative of minus x, which is minus 1. So this is step by step 3 times you are applying the chain rule. So dy by dx is equal to minus e raised to minus x cos of tan inverse of e raised to minus x upon 1 plus e raised to minus 2x. Next one, differentiate with respect to x. The function is y is equal to sine inverse of x root x. X is between 0 and 1. So again over here, first the derivative of sine inverse is 1 upon root of 1 minus whatever is there in the bracket, that square. So it is 1 upon root of 1 minus x root x whole square into derivative of x root x. So it is 1 upon root of 1 minus x cube into d by dx of x root x means x power 3 by 2. So x raised to n derivative is n, x raised to n minus 1. So on simplification you get dy by dx as 3 by 2, both are having roots. So 3 by 2 root of x upon 1 minus x cube. Next concept is the second order derivative. Now you're given the function y is equal to fx, you first differentiate it, you get f dash of x. When you again differentiate f dash of x, you get the second order derivative of fx. And it is generally denoted by f double dash of x or d square y or y double dash or y2, where your function is y is equal to fx. Let us take examples to find the second order derivative. Find d square y by dx square means the second order derivative for y is equal to e raised to x sine of 5x. So first you find the first derivative. So it is multiplication of two functions, e raised to x into derivative of sine phi x, which is cos phi x, into derivative of 5x, which is 5, plus sine 5x into derivative of e raised to x, which is same as e raised to x. So in short, dy by dx is e raised to x, phi cos phi x plus sine phi x. Again you find the derivative of this, you will get the second order derivative. So again over here, you are having two terms over here. So you use the multiplication rule. First we keep e raised to x as it is. So e raised to x as it is into derivative of the bracket. So that is again cos derivative is minus sine, 5x derivative is 5. And already 5 is there, plus sine 5x derivative is cos 5x into derivative of 5x, which is 5. So this was the derivative of the whole bracket, plus now keep the bracket as it is and take the derivative of e raised to x, which is same as e raised to x. On simplification you will get e raised to x minus 24 sine 5x plus 10 cos 5x, take 2 common. So d square y by dx square is 2 e raised to x into bracket 5 cos 5x minus 12 sine 5x. Next interesting example, if x is equal to a into cos t plus t sine t and y is equal to a into sine t minus t cos t, find d square y by dx square. You have to find the second order derivative of y with respect to x. Now remember this example, in this first we find the first order derivative and it is of the type where x and y are again functions of some other variable t. So we have seen this previously using the part of the chain rule. What we have to do is first we find dx by dt, then we find dy by dt, from that we find dy by dx, correct? And then the second order derivative. So first differentiate x with respect to t. So dx by dt, a is constant, cos derivative minus sine t sine t, t into derivative of sine which is cos plus sine t into derivative of t which is 1. So it is a t cos t. Now similarly for y find dy by dt. So again for y when you find dy by dt, you will be getting on simplification a into bracket t sine t. So dx by dt is at cos t, dy by dt is at sin t. Now dy by dx you can write as dy by dt upon dx by dt, correct? So dy by dx is equal to tan t on simplification, at gets cancelled. Now you find the second order derivative. So d square y by dx square, tan derivative is sec square. So it is sec square t into dt by dx, correct? So it is sec square t upon dx by dt, which is sec square t upon at cos t or sec cube t upon at, right? So don't forget this, since t is again a function of x, so you have to again find multiply by dt by dx, correct? So this should not be forgotten. So d square y by dx square is sec cube t upon at. Now see in this example, since you are given root of 1 plus sin x and root of 1 minus sin x, you need to simplify this using the rules of trigonometry, correct? Because you are having y is equal to cot inverse of something, so in the bracket whatever is there you need to simplify that. Now you know that sin 2x is 2 sin x cos x. So you apply that, 1 can be written as sin square plus cos square. So you convert the angle x to angle x by 2. So root of 1 plus sin x is sin square x by 2 plus cos square x by 2 plus 2 sin x by 2 cos x by 2. This is nothing but sin x by 2 plus cos x by 2 whole square. Hence what we have got is root of 1 plus sin x is sin x by 2 plus cos x by 2. Let this be equation 1. Similarly, root of 1 minus sin x will be cos x by 2 minus sin x by 2. Let this be equation 2. So y will be cot inverse of sin x by 2 plus cos x by 2 plus cos x by 2 minus sin x by 2 upon sin x by 2 plus cos x by 2 minus cos x by 2 plus sin x by 2. On simplification, in short, you will get cot inverse of cos x by 2 upon sin x by 2, which is cot inverse of cot of x by 2. So now you can see how it is simplified. Cot inverse of cot will give you the same angle. So y is equal to cot inverse of cot of x by 2, which is nothing but x by 2. And simply the derivative of x by 2 is half. Now it is given if x into root of 1 plus y into root of 1 plus x is 0, x is between minus 1 and 1, you have to prove that dy by dx is minus 1 upon 1 plus x whole square. Now remember, this is an implicit function. If you remember, we had discussed it is difficult to convert in the form of y. So first we need to simplify this. So now x into root of 1 plus y will be equal to minus y into root of 1 plus x. Correct? Square both the sides. So you will be getting on simplification x square minus y square is equal to xy square minus x square y. So on simplification you get x plus y is equal to minus xy. So y plus xy is equal to minus x. Correct? That means now you can write y into 1 plus x is minus x, or y is equal to minus x upon 1 plus x. So step by step you need to first of all get the equation in form of y is equal to some function of x. Now it is easy, you can find the derivative. So when you find dy by dx, you use the quotient rule. Numerator you will have over here u dash into v minus v dash into u upon v square. So 1 plus x into derivative of minus x, which is minus 1, minus x as it is into derivative of 1 plus x, which is 0 plus 1 or 1. And below you will have 1 plus x whole square. On simplification you will get dy by dx as minus 1 upon 1 plus x whole square. See, step by step the difficulty level of the questions, as I said, will increase. Next one, if y is equal to 3 cos log x plus 4 sin log x, show that x square y2 plus x y1 plus y equal to 0. Remember, your y1 is the first derivative of y with respect to x and y2 is the second derivative. So first we find the first derivative, which is y1. Again over here you are having chain rule. Derivative of cos is minus sine into derivative of log x, which is 1 upon x. So y1 will be equal to minus 3 sin log x upon x plus second term 4 cos log x upon x. Bring x on the left hand side, you will get x y1. Let this be equation 1. Now from y1 you find y2. Just take care in the simplification. First we find the second derivative for the first term of y1. So apply the quotient rule. So denominator will be x square, numerator it will be x into the derivative of minus 3 sin log x, which is minus 3 cos log x into derivative of cos log x, which is 1 upon x. Similarly, minus means the second minus 3 sin log x as it is into derivative of x, which is 1. Now similarly take the derivative of the second term of y1 and apply the quotient. On simplification, you will be getting x square y2 as minus 7 cos log x minus sin log x. You just have to apply the quotient rule and the chain rule. Now left hand side, put all the values in the left hand side and simplify. You will be getting the right hand side as 0. If y is equal to tan inverse of x whole square, show that x square plus 1 whole square y2 plus 2x into x square plus 1 y1 equal to 2. Again over here, first find y1 means the first derivative. Square means first of all the power rule. So 2 into tan inverse of x into derivative of tan inverse of x, which is 1 upon 1 plus x square. So y1 is 2 tan inverse of x upon 1 plus x square. So x square plus 1 y1 is 2 tan inverse of x. Now find the second derivative from y1. So apply the division rule, quotient rule for y1. So you will get 1 plus x square as it is into derivative of 2 tan inverse of x, which is 2 upon 1 plus x square, minus 2 tan inverse as it is into derivative of 1 plus x square, which is 2x. So on simplification, you will be getting the left hand side as 2 minus 4x tan inverse of x plus 2x into 2 tan inverse of x. So basically you will be getting 2, which is the right hand side. Now students, see, this is really important. You need to memorize the list of all these formulas. All the formulae are given in this slide. Just memorize all of them and you will be able to navigate all the examples. So here first of all the simple rules for differentiation are given, like the sum, difference, product, quotient rule, then the derivative of trigonometric function, derivative of inverse trigonometric function, the chain rule, and the derivative of exponent and logarithmic function. So just memorize all this formula and practice the examples. See, we have tried to solve examples based on all the different formulae for derivatives. Derivatives is really important, especially you will be using in physics also. So just practice a lot of examples, and in case of any query, please put in the comment section. Do like and share the video and subscribe to Math Practice for other topics on class 12th.